Over the last year, I've had the opportunity to talk to customers, present at conferences, and a lot of the talks that I've given are around Spring Boot 3. One of the major themes I've been talking about is runtime efficiency. This is the idea that, hey, we all have different workloads that we're trying to get to production, right? One size does not fit all. We're all building different types of applications that we're trying to get into production. So this really started in Spring Boot 3.0 with the introduction of ahead of time compilation, which is a precondition for building GraalVM native images. We'll talk more about that in a second. In 3.2, we saw the initial support for Project Crack, which is kind of similar to AOT in the sense that we're trying to improve startup times and lower memory consumption, but it just kind of goes about it a different way. And also in 3.2, we saw the first class support for virtual threads. Today, I want to focus in on ahead of time compilation. I like to go through and talk about what it is, why you might want to compile down to native. I need a reason to do so before I'm just going to jump into a technology. And then a lot of the follow-up questions are, that's great, that sounds like me, how do I do it? So what I want to do is go through the what, the why, and then we'll build a simple Spring application today using GraalVM's native image support, Spring Boot 3.2, which again came in 3.0. So if you're running that, that's fine as well. So this is going to be fun. Let's jump on in. All right. So ahead of time, or AOT, what is it? Tell me what it is, Dan. This is all about reducing startup time and memory footprint in production. Those are the two main goals that we're trying to solve for here. Java is very dynamic. We know it's a statically typed language, but it has dynamic capabilities. When we talk about things like reflection, resources, serialization, proxies, these things are dynamic things, and we have to think about those. What we're ultimately doing is AOT is a precondition for building these GraalVM native executables. AOT is a trade-off. There is this extra build step, a little bit less flexibility at runtime because we have to kind of tell the compiler, these are all the things that I want you to know about at runtime. So you're not doing these things at runtime. So it is a trade-off. There's this extra build setup, but this isn't something you're doing in your inner loop development. You don't need to run this extra build process every time you're like changing lines of code. This would be something that happens if you were to go ahead and check this into some CI/CD pipeline. So that's kind of what it is. It'll make more sense when we get into it, but that's the basics of what AOT compilation is. Now I want to talk about why you might want to compile to native. So the first is instant startup. We have this milliseconds for a native image instead of seconds for having to warm up an execution environment that contains something like the JVM, right? Again, no warm up. We get those performance benefits immediately. We're also using lower resources, right? So lower memory consumption. There's no JIT compilation happening. We have this native executable. Because we are kind of closing off the dynamic capabilities at runtime, we're saying, these are all the things I want you to know about at runtime. We can think of it as having a reduced surface attack, right? Because we are not doing these dynamic things at runtime. Because we're building these smaller applications, these smaller native images, we can put them in containers, and those are smaller, easier to deploy. And guess what? When you have smaller containers, that can lower your compute costs. So we get a big reduction in infrastructure costs. I say big, but it really depends, right? Like if it's one app, may not be that big of a savings. But when we talk about, hey, I saved this much on one particular instance, what if we're scaling that instance 1,000 times, right? So those are some of the reasons why you might want to compile to native. Now let's talk about the use cases. And I like to start at the bottom, some recommended uses for native images. So again, if we're in an environment where we have lower resources, we only have so much memory, we only have so much CPU available to us, then building a native image that takes up less of those resources is a good use case. The big one for me is function as a service, right? If we are deploying something to the cloud that uses a function, and this is, so the classic example I give is on something like AWS Lambda, right? If we are building a function that is going to be deployed to the cloud, this function needs to start up when it needs to take a request, take that request in, do something with it, process it, return a response, and then shut down. Normally, in the past, Java hasn't been a good candidate for this, right? Because it needs to warm up the execution environment, start up a JVM, then be able to process the request. And if that takes 4 or 5 seconds, that's not really a good use case for doing that. So now, when you have a native executable, you get that immediate startup time. It's taking less memory. That's a perfect candidate for function as a service. Again, on the same lines, scale to 0. I want to put an app out there. It's not going to be taking requests every single second of the day. It doesn't need to be running all the time. It only needs to come up when it needs to serve a request. And this came up a lot because I was working on a little side project and somebody said, "Where are you going to host this?" I said, "You could probably put this on something like AWS Lambda." And they came back to me and said, "Well, isn't that going to get expensive?" And I said, "Yeah, if I put it on a server and have it up and running all day, but for my startup that I'm just trying to get some requests into, I'm not going to be taking requests all day." I use the example of a newsletter. If I was starting a newsletter and I needed a service to capture email addresses, right? I get 5, 10 newsletter signups a day. I don't need this thing that's up and running 24/7, right? It just needs to take a request, process that, shut down, wait for the next one. So those are great use cases for something like a native image. The last one is CLIs. I've been building a lot more CLIs, especially in my role, being able to write tools that I can use for my day-to-day work. I might have in the past reached for something like Bash, but I don't use Bash all the time. In fact, if you asked me to write a for loop in Bash right now, I'd probably have a hard time doing it because I don't do it every day. It's not like my native language, right? But you know what is? Java and Spring. So I'm able to write CLIs in something like Spring Shell using Java. And this is a familiar environment for me. So what I can do is take that Spring Shell application and go ahead and compile that down to native. So I can run that natively on my machine, instant startup, runs fast. Again, a really great use case for it. So those are some places where you might want to compile down to a native image. What about where you might want to assess? So things like microservices, container image distribution, Kubernetes. So I have this back office app that just sits on a server. It doesn't have a bunch of throughput. Maybe that's not a great case for it. So these are situations where you might want to assess, are we going to get any benefit out of it? Where the JVM is likely better are things like high traffic websites, big monolithic applications. You have huge amounts of memory and CPU. You are doing frequent deployments. So again, the JVM is really good at optimizing in this scenario. We're getting a whole bunch of throughput. We are taking requests all day. We have it up and running 24/7. The JVM can look at that code and optimize for it. So maybe the JVM is likely better. Again, I talked about it at the beginning of this video. We're giving you options for all the different types of workloads that you're trying to take to production. So that is my what, why use cases for native images. Now that we got that out of the way, let's head over to start.spring.io and create a little sample application that walks through this. All right, so we're actually going to create 2 apps here. The first one's going to be very simple. We'll just kind of create a simple hello native application. And then the second one is I'll go and talk about like building a native application for a CLI. So let's start here with this one. We're going to use Java. We're going to use Maven, the latest version of Spring Boot. And I'll go ahead and fill this in. And I'll say dev.danvega. Let's call this hello native. And then I'm going to use Java 21. You can use whatever, Java 17 if you like. So I'm going to fill in the GraalVM native support. And I'm going to go ahead and generate that and open this up in my favorite IDE, IntelliJ. You can open this up in whatever text editor or IDE you're most productive in. All right, so for this one, we're not actually going to have to write any code. I'm going to go ahead and open this up. This is just our main class. But if we look in the pom.xml, because we chose that native image plugin from Graal, we have that as a build plugin. Now, the only other prerequisite for this is that you will need to be running a specific JDK. So if I look at Java version, you can see that I am running the GraalVM 21 version. So if you want to, you can go ahead and open up something like SDK Man and take a look at that. You can pull the JDK for that down from there. Once you have those two things in place, the correct build plugin here and the correct JDK, that is all you really need to do. Now you can go ahead and add your own code to the application, whatever you're going to do in this app. That's fine. In fact, maybe we can just add something so we have something here. Let's say that we wanted to add a dependency for Spring Boot Starter Web, and that comes from there. Let me reload this dependencies. I'll create a quick class. We'll call this Home Controller. This is going to be a REST controller. And in this REST controller, we'll have a simple get mapping for the root. And all we're going to do is return a string, and we'll say return hello world. So actually, let's say hello native, right? So that's it. That is the simple REST controller that we're going to do. Now, how do we go ahead and run this as a native application? So normally from our application, we can run this. We can also build a jar file. So if we look in here, we have some properties here. We are basically building out a jar file. So what we could do is we can come in here and say Maven clean package. And what we're going to do is in the target folder, once this is done, we will see that we have a jar file and an Uber jar at that we can go ahead and deploy to whatever production environment supports Java. So now what I can do is I want to build a native image. So the way that we do that, we can use that Maven wrapper. And we're going to switch over to the native profile. So we're going to say the profile we're using is native. And what I want to do is called native compile. So one other thing I might do is I might come in here and say skip tests, right? And then this is going to go through and natively compile our application. Now, again, we talked about it in the slides. There is an extra step here. There's a trade-off. This is a longer time to go ahead and build this artifact. But again, this isn't something I'm doing all the time. I'm writing my code, I'm testing my code, I'm manually going through and checking out my application to make sure things are working. Then I'm building the artifact that is going to go to production. The same way that you're not building a jar file all the time and running a jar file. We're doing our normal development, and then we're going to go ahead and build this native image. So I'll go ahead and through the magic of video editing, we'll go ahead and jump forward and be done with this. All right, and so now we're done. So now we have a jar file and a native executable in there. So if we were to run our regular jar file, we might do something like java-jar. And let me get rid of my cursor there. And then we could say, hey, in the target directory, there is a hello native snapshot jar. And if we run that, we see our application started in 1.094 seconds. And if we send a request to the root endpoint, we'd get the string hello native back. So I'm going to go ahead and stop that. And now we can go ahead and run our native image just by saying target and then hello native. And we see that it immediately starts up 0.04 seconds. And now there isn't a huge difference there because this is a pretty basic application. But I bet if you were to test this against some of your bigger applications, you're going to see a much bigger difference. And you're going to also see a reduced footprint. This is going to take up way less memory than the jar file would. So that's a quick example of building out your first native application. Again, this was a simple example. I want to go in and create one more project, and we'll create a nice CLI that we can run on our own machine. All right, so we're back. We're going to create a new application, pretty similar to the last one, but this is going to be a Spring Shell application. If you've never used Spring Shell, don't worry. What we're focused here is on the native bits. We're going to turn this into a native executable, so then we can just run this as an executable, a native application from our local machine. Again, a great use case for like building your own CLI tools. So again, I'm using Java, I'm using Maven. Let's call this hello CLI, and I'm using Java 21. I'm still using that GraalVM native image support, but I'm also going to pull in the web support and the Spring Shell support. I think with that, that's all I really need. I'm going to go ahead and generate this, download this, and open this up in IntelliJ. All right, so I said, don't worry if you haven't written a Spring Shell application before. I have some tutorials on the channel if you're interested in that. But I'm just going to create a new class. I'm going to call this hello command. And this is going to be a shell component. I'm going to paste in some code real quick. This is just a method so that when we go ahead and run the application, it opens up in this kind of interactive shell. And we're saying, hey, we have one method available. The method name, the key for it is hello. The value is, hey, this is just a description of this. All it's really doing is returning hello world. But obviously, we can get much more complicated with whatever we need to do here in our CLI. So I'm going to go ahead and just run this as a regular application. So let's run this, see if this starts up. And it does, and you see it drops us into a shell. We can always say help to find out what commands are available to us. Here are the built-in commands. Here are the commands from our application, one of which is hello. So if I go ahead and type hello, then I get the hello world returned to me. Again, nothing groundbreaking, but we should see that we could start to build on this. So I'm going to go ahead and stop this. And what I want to do is turn this into a native image. One thing I will do, and I'm just doing this because I've run across this before in my applications. When I turn this into a native image and I run this on my local machine, I don't want the logging. I don't want like the Spring banner. These are things that I don't care about when I'm in like an interactive shell environment, right? So I'm going to go ahead and turn those off. I'm setting my logging level root to off, and I'm setting my banner mode for Spring to off. And that'll just clean those two things up when I'm in a CLI environment. So that's it. We're going to do the same thing we did last time. We're going to come in here. We're going to say Maven W Dan, and we're going to say -p. We're going to run the native profile. We're going to run native compile. And this is going to go through, take a look at our application and use that AOT processing to look at all the paths of our application. I'm not doing anything crazy with reflection or proxies here, at least I don't think so, but this is the nice thing. All of the Spring projects in the ecosystem have been updated to work with GraalVM. So it knows, it has all of that reachability metadata to say like, if you do this, here's where you can find this class. And so it's putting that all into GraalVM as part of that compilation process. And now it knows when it builds that native image, if you do something at runtime, it knows about that class. If you didn't tell it that, it wouldn't know about that class. So most of the time when we're dealing with Spring projects, you don't have to worry about it. That's been done for you already. Now, if you're doing your own dynamic things like creating proxies or doing reflection, then these are things that you'll have to provide hints for. So again, I would go ahead and take a look at the documentation for that. There's a great section on getting started with GraalVM, and I'll leave a link to that in the description below. But again, through the magic of video editing, let's go ahead and jump forward to when this is done. All right, and there we go. That has completed. And if we look in the target folder, we now have a native executable called Hello CLI. So this means that now I can just run that. I can go into target, say Hello CLI, and it will drop me right into that shell. No logging, no Spring banner. I'm right in there. I can say help. I can see that my hello command is available. I can run that and I get that hello world return. So now what I could do is I could take this native executable and put it somewhere on the path where I find native executables on my machine, right? So I'll exit out of that. I've created an alias for that, basically pointing to that native executable. So when I type in YouTube in a shell, I'm dropped right into that application. And now that allows me, now this one is a little bit different. It loads a bunch of data first, not the most optimized thing, but it's a personal CLI tool, so it doesn't really matter to me. So that will drop me into that executable and allow me to go ahead and do some things. So this is a really great use case for building tools, and it drops me right into shell. Again, this is a previous application I wrote. Now I can look at that and see that, hey, I want to get a list of all the videos on my channel, or maybe all the recent ones. So I could type in recent. Here are some recent videos that are on my channel. So again, I really enjoy this use case, building kind of my own tools in Spring and Spring Shell, and then compiling them down to native executables. All right, I think that's where we'll call this a wrap. We had a lot of fun today. We went through the what, the why, and the how of building native executables with Spring and with GraalVM, and kind of what goes into them, and kind of the use case for them here today. So I thought we had some fun. Again, we've just kind of hit the tip of the iceberg here, right? We built some pretty simple applications. We could get pretty sophisticated with that. And obviously, the bigger applications we build, the more things we might have to deal with as far as building these images. But this is really exciting because, again, as Spring developers, we aren't all building the same types of applications. We're all building different apps that we're trying to get into production, right? And these are the tools that are helping us with all of those different workloads that we want to get into production. So again, hope you learned something new today. If you did, do me a big favor, give me a thumbs up, subscribe to the channel, and as always, friends, happy coding.